There's a lot of these in the book. At around about page 168, 169. So if they give you expressions like this and they say simplify, you're trying to get rid of the denominators, probably the first thing to do. The thing under the fraction, okay? So can we divide 2x by 2? Yes, we can. That would give us x. Can we divide minus 6 by plus 2? Yes, that would give us minus 3. So this one sort of ends up very, very simple as being simplified x minus 3. And that's a lot easier than 2x minus 6 divided by 2, isn't it? So you can think of it as being split up as 2x divided by 2 minus 6 divided by 2. This and this are exactly the same thing. You're taking a half of 2x and you're taking a half of 6. If we look at the second one, we've got x minus 4 on the bottom. So can we in some way create an expression where we get x minus 4 on the top? Well, yeah, we could. If we took an extra x out the front here, look, x times x would give us x squared. X times minus 4 would give us minus 4x. So by simplifying and taking x out the front, I get x minus 4 on the bottom. And look what happens now. I have already, on the top, I already have x minus 4 on the bottom. Anything divided by itself is 1. X minus 4 divided by x minus 4 is 1. So we get the answer of this rather complicated looking expression is actually just x. So we factorize by taking x out of the front. It gives us x minus 4. We already have x minus 4 on the bottom. X minus 4 divided by x minus 4 cancels, giving us x. Then we have 6y squared minus y. Well, we've only got one y here and we've got 2y on the bottom. So we can't make it as simple as we would like, but we could factorize y out here. If we took y out the front and then we'd multiply y by 6y to get 6y squared, and we'd multiply y by minus 1 to get back to minus y, divided by 2y. My y's now cancel, giving me that I get 6y divided by 2 minus 1 divided by 2, if I expand that out. 6y divided by 2 is just 3y, so my answer is 3y minus a half. And that's a lot nicer than what we started with. So the whole idea about factorizing is to try and get an equation that looks a little bit simpler than what we started with. So look at what's on the bottom of the denominator, of the fraction, the denominator. It gives you a good clue as what they want you to try and take out here. What about here then? Well, we've got x plus y on the bottom. Let's see if we can in some way get x plus y on the top. If I wanted to get xy here, the number that I'd have to have out the front of my bracket would be y, because y times x would give me xy. And look, y times plus y would give me y squared. So I would get x plus y on the top and x plus y on the bottom. Let's double check that we've not made a silly mistake there. Let's expand this one. Y times x would give me xy. Yx and xy are the same thing. We just usually write it as xy. Y times plus y would give me y squared. And we haven't done anything to the bottom. So it is what we would start with. But now we have that the whole x plus y is divided by x plus y. Any term that's divided by itself is 1, giving us the final answer of y. So this complicated term here ends up being equals y. So this is the advantage of being able to factorize effectively. It really does simplify. And they will often ask you in a question, simplify as far as possible. So it isn't okay to leave it in this middle step. You have to then realize, oh, these two terms are the same, they can be cancelled. And then finish it off.